system. There's a little red arrow there you can see at the top right-hand corner of your screen. You can use that to open and close the control panel. There's an audio panel that you can use to select your audio mode. There's a questions box, and you can use that to submit questions. You can submit questions anytime during the presentation. We'll take those questions at the end of the presentation and answer as many of them as we can. See the little button to raise your hand. And the most common question we get is, can you get a copy of the slides? And we will send everyone an email within 48 hours giving you access to get the slides in a recorded version of today's session. So let's get started. Thinking back on what we saw in 2012, first and foremost, we saw the hacktivists go away. In 2011, LulzSec and Anonymous were all over the headlines. There were big public data breaches. It felt like every week where these guys were stealing information and just posting it online. And a lot of the ringleaders of those organizations ended up going to jail, and they got a lot quieter. But while that hacktivist sort of public nuisance angle went away, we saw the number of data breaches rise pretty dramatically in 2012 over 2011. On Data Loss DB, they count all the public disclosures of data breaches, and the number of disclosures is up 45% year over year. And that, interesting, the distribution of disclosures across the year is pretty much the same as it was in 2011. It's just that we had more in each month than we had last year. So we're seeing more data breaches. At the same time, we're seeing a lot of new database vulnerabilities get patched by the database vendors. And from our research team, we know a lot of new vulnerabilities are being reported. And there have been some real big ones. We had the first ever CVSS 10.0 database vulnerability that Oracle addressed. That's a stealth password cracking vulnerability. I'll talk about that a little bit later, but that's a big, scary one that they just fixed in October. And both Sybase and IBM really got involved in the patching vulnerabilities game this year. Saw a lot more vulnerability disclosures from those two vendors than we'd seen in the past, and that's likely because we did more research in the past year on those databases and found a lot of vulnerabilities fairly easily. We also had some database malware spotted in the wild by the Semantic malware research team. So they found samples of malware out there that was targeting SQL Server databases and specific financial information stored in SQL Server databases. And we hadn't seen too much of the big AV vendors picking up on database exploits in the wild before, so that was a pretty interesting event. And finally, we're starting to see a mind shift, just the beginning of a mind shift among corporate executives, that maybe this big compliance effort that we've been working on for years and spending our IT security budgets on for years really doesn't equate with security. And while we might be compliant, it doesn't mean necessarily that we're secure. We're starting to see a change of mind around that, and I think that's very encouraging. Now, going into 2013, not a lot has really changed. Databases continue to be the primary target. Year after year, we've got over 90% of records that are stolen being stolen out of a database. And that's no surprise. All of our data effectively is stored in databases, so when folks want to steal information, the databases is where they're going to go. At the same time, database patching cycles are still extremely slow, unacceptably slow, 6 to 9 months on average for an organization to patch a production database. That leaves vulnerabilities for 6 to 9 months on average, known and exploitable in those production systems. And if that was a Windows vulnerability, that would never, ever be allowed. But when it's a database vulnerability, somehow we're able to turn kind of the blind eye on it. And I think that's going to come back to bite us. The same old attack vectors continue to yield success. So I've said this in my kind of yearly talk every year for a few, but SQL injection is still working. And it's still just so easy to go find sites that are vulnerable and break into databases that way. But at the same time, we're seeing powerful new attacks emerging that are just surprisingly easy to exploit. The attacker's toolkit for database exploits is much bigger than ever. And because that mean time to patch is so slow, as these new vulnerabilities come out, the number of highly exploitable vulnerabilities that the attackers have exploits for just kind of goes up and up. Finally, we seem to have seen the cost for a data breach reach a steady state at about $200 to $250 a record stolen. And I don't see that changing over the course of this year either. As data breaches continue to happen, organizations are going to continue to pay and pay in a pretty big way for every record that they lose. So here's my assessment of the top database risks for 2013. Number one is SQL injection. SQL injection has been at the top of the list for a long time, and it continues to be, although the threat around SQL injection is evolving and in some ways becoming more significant. Number two is password attacks. We've got the same old issue with weak passwords that we've had forever, but we've also got a new breed of password attacks that are extremely dangerous. Number three is improper and ineffective access controls. I'm just reading about far too many data breaches that were caused by an employee, a contractor, that had more privilege than they ever should have had. It's the easiest way for someone to take your information if you just give them access to it. We continue to see that as a really big issue going into 2013. Number four are database Java exploits. Basically, all the big database vendors are shipping Java systems with their databases, which offer a lot of great new functionality, but also a lot of new attack surface area. And we're seeing some significant vulnerabilities in those systems that leave the database servers wide open to attack. And number five are misconfigured database security settings. It's been a problem forever, but the databases are complicated, and if you don't set them up properly, the security systems aren't effective. And we continue to see folks struggling to set their database security systems up properly. Let's talk in a little more depth about each. First, SQL injection. There's just still so many vulnerable web applications. I mean, just a mass of vulnerable web applications that are out there. And if you're looking for SQL injection, go ahead, try it yourself. It's fun. Type single quote or 0 or 1 equals 1 dash dash into an input box on a web application and see what happens. The good news is most of the really valuable web apps out there, your banking website, the Amazon.com e-business websites, they're not, by and large, vulnerable to SQL injection. But the mom and pop shops that are out there, the bulk of the websites that are out there haven't done anything to protect themselves from SQL injection. So there's still a lot of opportunity for attackers to go after. The thing is, the really scary stuff isn't the SQL injection at the web application level. If you do a decent job restricting your web application's privileges, there's only so much damage that can be done there. It's the SQL injection inside the database that's really scary. Every major database vendor out there, we found SQL injection vulnerabilities in their platforms. So we've tried stuff like injecting SQL into table names, column names, the parameters of functions and stored procedures. And a lot of times the SQL we inject into those spots runs with administrative access, which means we can do simple stuff like grant ourselves DBA access to the database and with one line of code take complete control over a system. In 2012, in particular, we saw Sybase disclose a rash of very powerful SQL injection vulnerabilities that were super easy to exploit, that gave an attacker complete control over a database system, going from just no privileges at all, only the ability to log in. And again, these inside the database SQL injection vulnerabilities, you need to patch the database to fix them. This is the database vendor's code, not something that you've written or installed on top. So again, you're in this 6 to 9 month or more gap while your system gets ready for the patch cycle and you do your testing and scheduling and preparation. Password attacks. So we've been talking about password problems forever in the security business, and IT staffs have put together policies and procedures to try to enforce strong passwords. And all that's really happened is the general public has learned how to remember or how to put together easy-to-guess passwords that meet password strength requirements. So you've got password strength requirements, things like minimum of 8 characters, must include upper and lowercase, must include a digit or a special character. And what folks end up doing is sitting down and thinking about it. What can I remember that meets those requirements? Hey, look, password 1 with a capital P. That passes all the tests. That's certainly an easy-to-guess password. And I use this example all the time. There's just so many easy-to-guess passwords that pass these password strength tests. Passwords are just, they're a struggle while people insist on remembering them. And of course, there's software you can use to help you have passwords that you don't need to remember, but folks find it scary not to remember their passwords. At the same time, database password cracking software is just freely available. Go on to Google and or your favorite search engine and type database password cracker, and you're going to find dozens of very easy to use, freely available tools that will attach to a database and just start cracking passwords for you. And then we've got the new password vulnerability. So in October, with the October CPU, Oracle patched a vulnerability called stealth password cracking, which is an offline brute force password cracking vulnerability. And what that means is an attacker can sit and guess passwords for a user all day and all night without any interaction with the database. So maybe one failed login against the database in total, and they can guess billions or trillions of different passwords until they get the right one. Now, password guessing software goes fast. You can easily find password guessing software that will guess in excess of 10 million passwords a second. Now, when you start to count at that rate and maybe distribute the work across a couple of different systems, it's easy to pop up a few systems in Amazon's cloud these days. You can be cracking passwords at ridiculously high rates. So a vulnerability like this, left unpatched, really makes it easy for an attacker to get ownership of any one of your databases that hasn't been patched in your environment. It's vulnerable to this issue. So it's something to really think about. This is really going to be a big problem if people don't get that patch installed. It just makes it too easy for attackers to take over Oracle. And Oracle's typically the most valuable database out there, so we keep our heavy-duty data. Improper and ineffective access controls. So the database vendors, at least most of them, offer comprehensive role-based access control systems. They're great. They're really powerful, and they give you all sorts of flexibility in defining who can access what data. The thing is, comprehensive means complex, and with complex, it means really hard to follow. So it's very difficult to look at a database and just figure out through that complex access control system who's got access to what. And to make matters worse, every database has this feature called public. Public is a way of granting privileges to all the database users at the same time. Now, the database vendors have made public impossible to manage. They've created a list or a situation where the number of grants to public in a default installation is into the tens of thousands. And there's just no way to separate the wheat from the chaff there and figure out which of those public grants are good, which ones aren't good, or even manage adding additional public grants. How do you know what you've added when there's already thousands and thousands and thousands of privileges there to read through? So that's a real problem that we're going to continue to face. It's, as I said, it's almost impossible to determine what database privileges a user has at all, at least not by looking directly at the database without the help of some third-party tools. And on top of that, even organizations that could know what privileges their users have, so many organizations don't have any definition of what it means to be a privileged user in a database. And if you can't define what it means to be a privileged user, that means you can't make a list of privileged users. And that's pretty important information to know and to be able to list out, or who are your administrators, who are your privileged users, and that all starts with the definition of what it means. Otherwise, you may have a situation where you think you know who your admins are, but it ends up that a lot more folks have those admin rights than you ever thought. Finally, we found that the longer a system has been around, the bigger the privilege management nightmare tends to get. So legacy systems, older systems, it's just so hard to manage privilege and manage least privilege in a database. The DBAs tend to just do what it takes to get the job done, and that means close their eyes to managing least privilege and, effectively copy and paste existing privileges in the system to make things work. That just ends up with a privilege nightmare. It's very difficult to unravel. And so with your systems that have been in production and in play for years are the ones you really got to think the most about, because that's where you have the biggest potential for improper privileges being granted out to a significant number of users. Database Java exploits. So over the past few years, all the database vendors in their major releases have included Java systems with the database. At the same time, all the database, what that does is it just brings a whole new level of functionality to the database developers. Right, now you can load and run and execute any functionality you want using Java through the database engine. The thing is, that also changes the game for an attacker. If an attacker can load and run any code they want on your database server, well, they can load and run malware and really own the database server and use that as a launching point for owning your entire environment. Now, all the vendors with these Java implementations, Oracle, Sybase, IBM, they've recently patched critical vulnerabilities that allow attackers to load and run arbitrary Java. In 2012, it was Sybase and IBM. In 2011, it was Oracle patching this kind of vulnerability. But in each case, the database was allowing public, that's any user with access to the database, the ability to load and run any Java code they wanted to on the database server. And that meant complete ownership. So this Java stuff is really cool, but too many folks have just left it turned on in the database. It's typically installed by default. They're not using it. And in turn, it's leaving them vulnerable to attack. So Java is something you got to think about. If you're going to use it, great. Use it, but keep it patched. If you're not using it, disable it right away. And don't let that be the avenue of attack for a hacker to come in and take ownership over your database environment. Finally, we've got misconfigured database security settings. So let me make it simple. If you don't set up your database security features correctly, they just don't work. And you've got to remember that databases are shipped configured for convenience, not for security. The database vendors want the database to be easy to use out of the box, not secure and hard to get into. So you're going to need to turn the security features on yourself. Now there's some security features that the database offers, or the databases offer, that are options that just shouldn't be options. Even if they're turned on by default, these things should permanently be on. So you should be aware of DB2's Trust All Clients configuration option, which basically turns off authentication and authorization. You got to be aware that SQL Server and Sybase both allow you to use a blank password for the built-in SA or system administrator account. In fact, you can argue that blank is the default password for the system administrator account in those databases, and that just makes no sense. Oracle, we've learned, allows anyone in the network to add nodes to a running cluster, which basically allowed you to proxy connections to an existing database and hijack credentials and hijack complete connections to database systems. And we learned that from an exploit that was posted by a researcher named Yaxin Korit, an exploit called TNS poisoning. That showed us exactly how an unauthenticated, unauthorized user could add nodes to a defined cluster and effectively steal user sessions in databases. So that's the result of not configuring additional security on those connections, and again, just leaving the security features the way they come out of the box, which is not turned on. That's a good example of how that can leave your database vulnerable. Let me share some tips with you going into 2013. Get started by devising a database security plan. So you want to start with an established DBMS checklist. There's a couple that are published out there. This is SPIG from the Department of Defense, and CIS, or the Center for Internet Security. They're both great starting points for understanding how you should be configuring your database for security. This has got great guidance on SQL Server and Oracle. CIS has got a little broader guidance. They cover Sybase, DB2, and MySQL as well. You're probably not going to want to use the checklists out of the box exactly the way they are. Think of them as a starting point. Customize those checklists to meet the needs of your organization. And make sure that you're paying attention to any industry regulations that you've got to follow. So if you need to comply with PCI, with HIPAA, with Sarbanes-Oxley, make sure you're rolling that into your database security plan. Then once you've got a policy of what you should do to secure your databases, build a rollout plan to roll that policy out into production. Pick the couple of highest priority issues you're going to fix first. So do something simple like fix your default accounts with default passwords across all your databases, and then move on to the next set of issues. It's going to make your security rollout much more successful and much easier to measure. And then just keep layering on additional checks and tests as you're able to close out high priority issues. Next, you want to locate your really security sensitive systems. So you want to consider which systems have the biggest business impact if they're compromised. So you want to look for all your sensitive information and all your customer information. If that goes out and gets stolen by a competitor or gets posted online, that's bad news. You want to also find any system that's critical to operations. So if a system goes down and it turns off your manufacturing plant, you want to make sure that that system is really well protected. So these are the kind of systems you want to put at the top of your priority list for security fixes. You don't want to put them in last on the list because you're afraid you're going to break the system with the security fix. These vulnerabilities that the vendors are fixing are severe, and you really got to take the security of the system kind of first and foremost. Then you want to minimize your attack surface. So the database vendors ship with a lot of features turned on in the database, again, for convenience. Make a list of the features you're using and turn off everything else. More features just means more code means more bugs means more vulnerabilities, and that means more potential for getting attacked. So don't let an unused feature be the avenue that an attacker uses to get in and take over your system. Just take those unused features right off the table. You want to fix your default blank and weak passwords. So all the databases are going to come with accounts pre-installed, and they're going to have default passwords. And when you install applications, they're going to do the same thing, pre-install accounts with default passwords. You've got to change those passwords. Those passwords are they're documented, they're published on the internet. Anyone who wants to know them knows them. You really got to be diligent about changing defaults. You want to make sure all your databases, you use all the features in your databases to check passwords that users input to make sure they're complex. So to turn on any password complexity checks that you can find. Not every vendor's got great complexity checks, but use what's available. You want to make sure there's no default blank or weak passwords. I talked about defaults already. Blank and weak passwords are important as well. You can find those in your system by picking up and running a database password scanner. That'll pinpoint the most easy to guess passwords out in your systems. Make sure as an administrator you're using different passwords for each system, so don't let the compromise of one system compromise lots of others. And if you can, use external authentication. That tends to be much more difficult to break, much easier to manage regular password changes. If you can go to an external authentication system, I suggest you do that. You also want to figure out how to regularly patch your databases. The patches are really critical. There's an awful lot of significant vulnerabilities that are getting fixed. These vulnerabilities tend to be very easy to exploit, and if you don't patch your database, you leave yourself exposed. So you want to patch as quickly as possible. If you do that in conjunction with some database intrusion prevention, some real database activity monitoring with attack signatures, then you can prolong the time that you need to take to patch. You can reduce your risk by knowing if somebody's attacking your system up until the time you've patched. But I'd consider getting good at rolling back patches as a primary option. If you can learn to roll a patch back very quickly, then you can really just go out and patch. And if it happens to break something, you know how to roll it back. But at least you can get way out in front of the security issues and potentially get ahead of an attacker who wants to take advantage of the new vulnerability by just rolling out patches quickly and knowing what to do if the patch is disruptive. You want to do your best to implement least privileges. So try hard to make sure your employees only have the access to the sensitive data that they need to do their jobs. You want to do some kind of a mapping of job functions to privileges on IT assets, and you want to make sure you never assign new privileges to guest accounts or to public. You should get tools to help you untangle the web of user entitlements on your highly valuable systems. Make sure you're not guessing at who has access to your critical intellectual property or to your customer data. Spend the money that it takes. It's not terribly expensive to do an assessment of access controls in a database, and get control over exactly who has access to what. Finally, encrypt sensitive data, both data at rest and data in motion. If you've got sensitive data stored in clear text in a database, any DBA can access it. So you can use encryption to solve that access control problem. But if you do, make sure you're not making the DBAs the encryption administrators. Don't give them the keys to the data that you're only encrypting to keep them out of. And then make sure that you don't allow sensitive data to travel across your network in the clear. All the database vendors have built-in, simple, easy-to-use network encryption. It's transparent. Just turn it on. Your clients will talk to your database encrypted, and no one will be able to sniff the wire in your organization and pick up your sensitive data. It's not just about the technical controls. You've also got to do some training and awareness. So remember, do regular training of your employees on corporate security best practices. Make sure everyone's aware of what the rules are. Have a program to regularly reinforce the policy. Make sure you've extended the notion, and this is really a mind share process, so that folks understand that as critical as it is to protect the perimeter and to put up firewalls and have antivirus up to date and all of that, it's just as critical to protect the vaults, the databases where we store the really valuable stuff. And so make sure that everyone's thinking about extending those protections from the network perimeter all the way into the database where your critical data is stored. And that means performing regular audits, pen tests, misconfiguration checks on your databases directly, and using database activity monitoring to make sure sensitive data is not being abused or accessed inappropriately. So if you're only going to do a few things, here's the top 5. Classify your business critical databases and fix them first. Eliminate your default blank and weak passwords. Remove any unused features and components from your databases. Enact a database patch management strategy and make sure your databases are getting patched in a timely manner. Get way ahead of that 6 to 9 month industry average. And finally, examine user entitlements and revoke as many unnecessary privileges as you can. Make sure you know what it means to be an administrator, and only the people that should be administrators have those privileges. In case you don't know about us, Application Security Incorporated, we're the leader for database security risk and compliance software out there. We help more than 1,300 organizations secure and protect their databases while achieving regulatory compliance. Our solutions are well regarded and known to lead the industry for protecting databases, both DB Protect, our enterprise security solution for databases, and App Detective Pro, our solution for security practitioners, the software of choice for those who have taken database security seriously. And it's all built on top of Team Shatter. Team Shatter is our database security research team. It's the largest dedicated security research team on databases in the world. And we found more than 80% of the vulnerabilities that database vendors have fixed in recent years. A few final thoughts. Attackers are targeting your data center. Your defenses should be focused there as well. Most of the breaches that happened over the last year were avoidable through simple controls or were the result of just human error or failure. You really got to get in front of these common flaws and fix the simple stuff to really raise the bar for attackers and reduce the number of attacks that are happening successful out there. So in 2013, improve security and improve education. Re-educate your security team and your non-security professionals. Have a real awareness campaign and make sure folks don't do foolish things that get you in trouble. One thing you can do is get started today. Come to our website and download a 30-day no-cost trial of App Detective Pro. It'll help you find your databases, identify weak passwords on those databases, high-risk misconfigurations. It'll uncover the top vulnerabilities in databases for you. Well, you're welcome to come and make use of that software free for 30 days at appsecinc.com. So at this point, I'd be happy to take any questions. So you can type those right into your questions box. And of course, you can contact us at sales@appsecinc.com. So we've got some questions about does AppSec have any tools to evaluate the security of Hadoop? We currently don't have any tools for Hadoop on the market, but we're actively working on some Hadoop security testing. And stay tuned; you should hear some announcements from us in the near future about the availability of a product that'll help you do that. I have a question about ODBC. We see a lot of ODBC that have little or no access control. So ODBC is a protocol that we use for talking to a database. I believe it stands for Open Database Connectivity. So ODBC is like the means for making a client connection to a database. Access controls shouldn't be implemented there at that protocol level. So the idea of trying to restrict users from running ODBC, it really isn't effective. You want to make sure that the database where the data is stored and where those connections are eventually ending up is where you enforce your access controls. The security is most effective as close as you can bring it to what you're trying to protect. And as you protect the database and implement security right at the database level, that's where you're really wrapping your data in protection. So think of doing it at the database level rather than at the client or protocol level, and you'll be more successful. Another question, patching a database is not necessarily as straightforward as patching an operating system due to the application and other issues. So and it's just a comment, and that's the biggest driver on why database patching is slow. And Jeff, you're absolutely right. I mean, it's easy to say patch Windows and go out and patch all your Windows boxes at once. You certainly can't do the same thing for your SQL Server databases or your Oracle databases and expect everyone to be happy about it. But honestly, that's sort of where you need to get, to a point where you just push the button and go out and push a patch to all your SQL Server and all your Oracle, and be able to quickly react when that has an implication or impact on your apps. The database vendors do a pretty good job making the security patches pretty tightly encased so that they don't affect other functionality in the database, but it's certainly not unheard of for them to cause an impact to an application. And sometimes application developers use these vulnerabilities to make their apps work. So it's something you got to think about, but I'd advocate learning how to roll the patches back rather than the more careful approach of doing a lot of testing and making sure that a patch doesn't break an app. When you've got these big vulnerabilities in your database, I think your risk is just too high to take the luxury of all the testing. But of course, I'm not responsible if apps go down, so it's easy for me to say that. Got another comment that says compliance does equal security if and only if you're assessing your compliance 24/7. I actually couldn't disagree more with that comment. Compliance gets you the checkbox, but just because you've checked the box and you meet all the rules of your compliance 24/7 doesn't mean that you've protected your system. A compliance statement is only as good as the policy behind it, and if that policy doesn't really address all the security issues, and never in my career have I seen a regulatory compliance framework address anywhere near all the real security issues, you're just fooling yourself. You're just doing extra work to prove that you're really compliant all the time, and that may be very important to your auditors, but it certainly doesn't mean anything to the attackers that are doing something that your compliance program probably doesn't address to break into your system. So I think you've really got to look at security from a much more holistic perspective than the checklist that you may have for PCI or Sarbanes-Oxley, for example. There's a question about extending encryption to reports. Well, it's a great question. It depends on what you're going to do with these reports. So if you've got reports that include very sensitive data in them, I do recommend that you encrypt that very sensitive data, whether you do that by encrypting the systems that you ship it to, so by using whole disk encryption, or by encrypting the files and using tools like PGP, for example, to share encrypted files and decrypt them. Those are both great steps that you can take to ensure the privacy of reports and once they've left your protected data stores like your databases. It's a question about what App Detective Pro and I guess appsecinc tools in general do in reference to addressing advanced persistent threats. So I think the answer to that one's pretty straightforward. The persistent threat out there is typically looking to take your most valuable assets, and that in most organizations is their data. So the target of the persistent threat is typically the database. So if you're protecting your database, locking down the access controls, patching the vulnerabilities, eliminating the weak passwords, making sure that you've really got that database protected, and then monitoring the use of that database all the time to make sure nobody's attacking it, well, then you're really wrapping up the primary target of those persistent threats and security, and you're making it a lot more difficult, if not impossible, for them to be successful and get the data that they want to get their hands on. So that's the way I think of it. It's the advanced persistent threat out there is targeting the database, and to the extent that you can protect that database directly, given that these folks are going to penetrate your network perimeter defenses 100% of the time, the closer you can bring security to your data in your database, the better off you're going to be. There's a question about restricting DBAs from reading data, especially in a SQL Server environment. So you in SQL Server you have some options. So in SQL Server there's both the built-in system administrator role, which you cannot restrict in any way. But then there's a lesser administrative privilege set called control server. So if you build up your DBAs using control server rather than giving them system administrator, then you actually can deny them access to business data in the system and just give them control of the configuration and the schema of the database. So it's going to take some work to set it up, but you can actually use the built-in access controls in SQL Server to keep your DBAs out of your data. Now, Microsoft has also got a built-in transparent data encryption system to allow you to encrypt the data in your database. That can help you keep DBAs out as well, but again, if somebody's got the system administrator role, they own the crypto system, so there's, again, no restrictions. So you've really got to watch out for that SA or sysadmin role in SQL Server. If you turn that on, then the only way to keep, or if you give somebody that role, the only way to keep them out of data is to use third-party encryption solutions, and that's, in some cases, a dicey process as well. So there's a question about using Java for database access and what can be done to prevent SQL injection attacks. So when you're using Java, again, it's kind of the same thing as any programming language. If you're taking user input and you're going to pass that along in a SQL query, you've got to be very careful. You've got to make sure that you sanitize that user input carefully and make sure that they're not injecting SQL. You can do that by looking at the input directly. You can do that by parameterizing your queries. You know, I think the best resource out there to get information on how to write secure code in Java and other languages is from OWASP. Go up to owasp.org and check out their stuff. They've got a ton of really, really valuable information for you on how to write code and avoid SQL injection. There's a question about a partnership with database firewall and DAM manufacturers. There's really no difference between database firewall and database activity monitoring. These are just marketing terms that different companies use to describe their products. Everybody's really talking about monitoring database activity and being able to stop bad stuff when it happens. And just about every vendor who says database firewall or database activity monitoring has that feature set. So I think of those things as effectively one and the same. Next question is, database encryption is a hard issue in many organizations because of performance impact, and database is located in DMZs, so it can really be a worry about corruption in those environments. So database encryption can have a performance impact. It can be very significant. And database encryption doesn't solve many security problems. The only thing it can really do is keep your DBAs out of sensitive data in your database. And it'll only do that if you don't put the DBAs in charge of the encryption system. So 9 times out of 10, the database encryption I see deployed does nothing but hurt performance. It does nothing for security, and you've really got to think carefully before implementing database encryption. There's some valuable stuff you can do, but you've really got to understand what problem you're trying to solve and make sure encryption actually solves that problem and solves it in a way that's not going to crush performance in your system before you roll it out. There's a question if you should or could use a database activity tool and App Detective. App Detective is a database vulnerability scanner. So if you've already got a database activity monitoring tool and you're not doing database vulnerability scanning, you absolutely should use App Detective. You want to make sure you fix as many problems as you can before you spend a bunch of time monitoring and looking at monitoring records and getting reactive. Next question is Java and J2EE in the database strengthen security in the light of current security breaches by hackers. That's reported by international organizations, including in Europe. Is Oracle Corporation doing enough for security for Java, for both the database and web applications? So I'd say that adding Java to the database has just added more surface area to the database, and we've seen more big vulnerabilities because of those Java systems. So from my perspective, adding Java to the database has hurt security. And I guess that shouldn't be a surprise. Complexity is always the enemy of security. As we add more functionality and more complexity, we inevitably make things less secure. So I'd say that this the addition of any new functionality to the database is probably going to hurt security. Even new security functionality to the database tends to bring new vulnerabilities and new potential for misconfiguration, and often bigger risks than it actually solves. As for, is Oracle doing enough? Frankly, I don't think many large software vendors are doing enough. Oracle's a big successful company with a lot of money, and they could spend a lot more money than they currently do fixing security vulnerabilities and being better about security. But the same could be said for all the other database vendors out there. So I don't think they're any different. I think that in general, society needs to do a lot more about software security. And the reason why we don't is that the incentives really aren't in place for software vendors to do a better job. I mean, what bad stuff happens to Oracle or Microsoft or IBM or anyone else when vulnerabilities are found in their software? It doesn't tend to hurt their business or their stock price. So there's very little incentive for them to get crazy about fixing them. So it's kind of the world that we live in. If we care, we should all go lobby our government officials to change the laws and make vendors responsible for the security of their software. That certainly would change the incentives and likely the behavior. The question about my feelings about database vendors that don't reveal database vulnerabilities until they're public knowledge. Doug, my feelings are strongly negative in that regard. I'd love for vendors to be much more upfront about vulnerabilities. I think when they hide that kind of information, it's like, let's just give the bad guys who've spent the time or the money to go figure out what the vulnerabilities are the edge, and not tell the good guys about the risks that they need to avoid. I think the only way to get organizations to get serious about fixing security problems is to help them understand the risk. And if you're burying that information, then you're doing really everything you can to avoid having your users understand the risk. So I don't like it at all when vendors hide their security issues, and would love to see every vendor be much more upfront in their disclosures. At the same time, I'd like to see the vendors do a better job testing their fixes for vulnerabilities before they disclose, because there's just too many errors that are made where a vulnerability is disclosed, hey, we patched this, and the patch doesn't effectively fix the problem. So I'd like to see vendors be more open, but I'd also like to see them be more careful and more diligent in their fixing process. The follow-up question on the comments I made about compliance. And I'm not trying to imply that you make yourself more secure by not following your compliance regulation, not at all. I'm simply saying that your compliance regulation is, in all likelihood, incomplete and is not enough to make you secure. So certainly the compliance regulation is likely telling you to do all good things, and you should do those good things. But once you're done with those good things, it's not time to feel good about being secure. You've really got to do a true security assessment to find out if you're secure and if your state of compliance has done enough for anything to really protect your systems. We just see too many organizations that are compliant with whatever they think makes them secure get hacked, and then look dumbfounded about the fact that they're compliant but not secure. And the problem isn't that they weren't audited 10 minutes ago. The problem is that their state of compliance didn't put them in a state of security. The question on Oracle Database Vault and what my thoughts are on how that can be used to control access to data. I think Oracle Database Vault is a really powerful utility that can be used to control DBA access to some data in the system. It means bringing multiple administrators to any particular system, though, and of course having some kind of top-level administrator that can provision their own access or other people's access, so somebody's still got access to the data. But if you're going to use one database instance to host data for different applications that you want to have different administrators for each application, and it's really sensitive, Database Vault is potentially a good option for working that situation out. There's a question about avoiding using SA for applications to connect. Well, I guess my answer is if your app vendor is telling you that they need SA to connect to the database, then you should call the app vendor and complain and work with them until they can tell you minimum set of privileges to run their app. If you're running your apps as SA, then and somebody can compromise those apps, they own the database completely. So you really want to do your best to not use SA and not grant it out there, and push your software vendors not to require such powerful privileges to run their application. There's a question about if there are any known issues with appsecinc Pro. Like all software, we've got some known issues, but appsecinc Pro is pretty fantastic software. It's been in use for about 10 years now by folks to assess the security of their databases. It's pretty rock solid, and if you haven't tried it, grab that download and give it a shot. There's a question about, doesn't someone need full rights to the database, and how do you manage that risk? So Eric, somebody does eventually need full rights to the database, and you manage that risk, I think, primarily with auditing and monitoring. So your DBAs, you want to audit and monitor what they're doing, and you want to use your security team to do that auditing and monitoring, so there's some separation of control there. So the DBAs might need all the access, but you want to make sure that they're not abusing that access. And in the best case, you want to make sure that all the changes they make are controlled by change tickets, and then you reconcile the changes you actually observe with the approved change tickets in your system to make sure that they're only changing what they should change. But the answer there is to have checks and balances and use auditing and monitoring and potentially encryption as well to control the access that the administrators have. There's a question about MySQL. How vulnerable is MySQL? Should it be avoided? I think MySQL is about the same as most of the other databases. I wouldn't say that MySQL should be avoided. The source code is out there, so folks have had the chance to really look for vulnerabilities much more thoroughly than with some of the other database platforms. They do find some sometimes, but I don't think they're way out of line with any of the other vendors out there. So I think if you like the features that MySQL offers, and it's a nice but limited feature set, and the price makes sense, then go ahead and use MySQL. I wouldn't let fear of security be the driver that kept me away from MySQL. Got some specific questions about experience with appsec products. I think it's tough for me to answer those just here, so I'd be happy to reach out and make sure that we get in touch with you afterwards and talk through any specific product questions that anybody has. Please reach out to us if you've got the product through your sales rep, and be happy to address those questions. There's a question about, can a policy be put in place to change sysadmin passwords every quarter? I think, of course, you could put a policy in place like that. That's a business decision. Whether your teams are going to accept that decision and actually change the passwords is another question entirely. It's a good idea. There's a lot of great password vaulting solutions out there that vendors are offering that will automatically change those passwords for you on a regular basis. It may make sense for you to invest in that kind of solution. So that's about it. There is one question for me to describe a little bit about what our software does. So let me go ahead and do that. The software that appsecinc makes is database security software. We'll find the databases on your network. We'll scan those databases for vulnerabilities and misconfigurations and generate nice reports that you can use to understand where your issues are and how to fix them. We'll look at the access controls in your database and identify who your privileged users are. We'll tell you who can access what data and how they got that access and help you understand how to revoke it. And then we'll monitor your databases 24/7, identify any attempt to exploit a known vulnerability in your database, give you a complete audit trail of what your administrators are doing, who's accessing what data and when, who's making what changes and when, and really giving you a complete picture for the security and usage of your databases. So if that's the kind of solution you're interested in, then you can find out a lot about us at our website, appsecinc.com. So thanks so much for all the questions today. Thanks, everyone, for joining us. I'm going to wrap it up, and look forward to hearing from you in the future, potentially on our next webinar. Have a great day.